kind of belated New Year! Like we do every January, we figured we'd start off the year with a sneak peek at what space missions you can expect to hear more about during 2017. Some of these missions will expand what we know already, but others will venture into uncharted territory. Take Prospector-X, which will test technology for the first commercial asteroid prospecting mission. Asteroids are rich in water and metals, which can be used to power spacecraft or for manufacturing. But right now, we don't have a way to access those resources. So Deep Space Industries, an asteroid mining company from California, is designing technology to change that. Prospector-X is due to launch to low Earth orbit in September, and while it's there, it'll test 3 key technologies for later asteroid mining missions. First is the propulsion system called Comet-1, which uses water as a propellant. Prospector-X will test the optical navigation system, which will use 2 cameras to determine just how close the spacecraft is getting to its asteroid target. And finally, it'll test the deep space avionics, the electrical systems and computers used on the mission. If all goes well, the technology will be used on Prospector-1, the first commercial mission to survey and land on an asteroid, which will launch sometime in the next few years. A few months after the Prospector-X launch in December of this year, NASA will launch a new satellite to learn more about exoplanets. It's called TESS, the Transiting Exoplanet Survey Satellite, and it'll search 200,000 of the brightest stars near the Sun to try to find planets around them. It'll look for planets using the transit method, which involves searching for periodic dips in the star's brightness, a key sign that there might be a planet passing in front of it. Then various telescopes back here on Earth will confirm that the objects really are exoplanets and that TESS's observations were correct. Those other telescopes will observe how the exoplanet's gravity affects their host stars, which will help researchers determine the masses of these new planets and figure out which ones they want to study more. TESS is expected to find more than 2,000 new exoplanets, adding that to the almost 3,500 we already know about. Other missions, like the Kepler Space Telescope, have looked at exoplanets before, but the star's TESS studies will be 30 to 100 times brighter than what Kepler looked at, and it'll survey an area 400 times larger. Studying exoplanets can teach us more about how the Earth formed and what conditions need to be like for life to evolve, so we're about to learn a whole lot more about our universe. And finally, China is going to the moon. Since 2007, the China National Space Administration has been launching moon missions in the Chang'e program named after the Chinese moon goddess, and Chang'e 5 is due to launch in the second half of 2017. Chang'e 1 and 2 were both lunar orbiters, and Chang'e 3 was a lander that put the Utu rover on the moon in 2013. Chang'e 4 is another lander-rover combination, but it actually won't launch until 2018 after Chang'e 5. Meanwhile, this year Chang'e 5 will land on the near side of the moon and will collect and return lunar samples to Earth. These will be the first new samples brought back to Earth since 1976. Studying samples of the moon's rocks and soil can teach us about the early days of the moon, the Earth, and our solar system as a whole. If everything goes well for Chang'e 5, Chang'e 6 will launch in 2018 to return samples from the far side of the moon. That's never been done by any country, so it would provide brand new information about an unexplored part of the moon's surface. But if Chang'e 5 doesn't go as planned, they might try landing Chang'e 6 on the near side of the moon again instead of going around to the far side. It mainly depends on the success of Chang'e 5. All this is building up to China's first crewed mission to the moon, which they hope will happen by 2036. That's a lot of missions, and the teams behind them have been working hard for years, and it's finally showtime. So it looks like this will be a year of new discoveries, and you can be sure to learn more about them here at SciShow Space. Thanks for watching this episode, and special thanks to our patrons on Patreon for helping us make this happen. If you'd like to help us keep making episodes like this, you can go to patreon.com/SciShow. And don't forget to go to youtube.com/SciShowSpace and subscribe.
Previous record holder had a redshift of 8.68, but this galaxy has a redshift of 11.1. For comparison, the first